numerical differentiation. माइक बंद कर दें सब. numerical differentiation है. Now the first thing is we have forward divided difference. माइक प्लीज बंद कर दें. The divided and the derivative of the function f at x naught is limit h tends to 0 f of x naught plus of h minus f of x naught over h. This is the formula gives the obvious way to generate approximation f slash of x naught. Simply compute अली हमजा माइक बंद कर ले. Now this formula gives an obvious way to generate approximation to f slash of x naught. Simply compute f of x naught minus h minus of x naught for a small value of h. आप simply compute करो. Simply compute f of x naught plus of h minus of f of x naught divided by h for small values of h. Small values of h. Now we have an example. use the forward difference formula to approximate fx is equals to ln x at x naught is equals to 1.8 using h is equals to zero point 0.1, h is equals to 0.05, and h is equals to 0.01, and determine bound for approximation error. Approximation error. Now, forward difference formula will be f of x naught plus h minus f of x naught divided by h, and we know that here x naught is 1.8 and for h is equals to 0.1. So simply we have 1.8 plus 0.1 minus 1.8 over zero point 0.1. Therefore, we have therefore we have 1.9 minus 1.8 over zero point 0.1, and f of 1.9 minus ln 1.8 over zero point 0.1, and this is actually equals to 0.64185 389 minus 0.58778667 over 0.1 5406 722. This is actually forward difference approach when h is 0.1. ठीक है? Now next part is bound error. For bound error, we use the formulation this is called bounding error. ठीक है? Now fx is equals to ln x. Its first derivative will be 1 over x and second derivative minus 1 over x square h or f slash of theta is minus 1 by eta square into 2, and we are taking the absolute value at 1.8. H is 0.1, 0.8 square times 2 approximately equals to 0.0154321. Okay, this is called bound error या error bound. तो इसी तरीके से आप h की वैल्यू मैंने 0.1 रखी है, आपने सॉल्व किया. सिमिलरली we take h is equals to 0.05 and solve the above example, and we can take h is equals to 0.01 and do above example. तो यह आप खुद से भी कर सकते हो, इतना ज़्यादा इश्यू नहीं होगा. नाउ एप्लीकेशन एग्जांपल है, एग्जांपल नंबर 2, we have this is example number 2. The velocity of a rocket is given by this. Now we have to calculate the acceleration at a certain time. So if the velocity of a rocket is this, basically, you can say, so हाँ जी, ये आ गई एग्जांपल. Now, how can we solve this? The velocity of a rocket is given by this. Velocity है rocket की, ये given है हमें. ln 1410 power 4 1410 power 4 minus 2100 t. This is actually the function, और t movement है 0 से 30. Here v is given in meters per second and t is given in seconds. Use forward difference approximation of the first derivative. We have t, calculate acceleration at t is equals to 16 c 16 s seconds. Use the step size of h is equals to 2t, means 2 seconds. So how can we solve this? E of 16, E of 18, and acceleration, the difference between these two. एंड आखिर में आपने इसमें एरर कैलकुलेट कर लेना है. नाउ हम इसको सॉल्व करके दिखाते हैं. डेरिवेटिव ऑफ v ऑफ t। ये बात हमें पता है, रेट ऑफ change of velocity is called acceleration. Means derivative of जो आप फंक्शन का ऊपर भी निकाल लेते डेरिवेटिव लेफ्ट साइड पे, तो डेरिवेटिव ऑफ द फंक्शन t, यहाँ पर, या आप यूं भी कह रहे थे v slash of t is actually known as acceleration in terms of t। सही है। अब at time 16 seconds, 16 seconds में acceleration actually या फिर v of t slash of t is equals to, आप फॉर्मुलेशन करते थे तो t plus t naught minus v of t over h। Here t naught is 16 seconds, 16 seconds, and step size is 2 seconds. Therefore, acceleration at 16 will be equals to v16 plus 2, यूं इसको यूं लिख लो, t naught plus h, and this is t naught, t naught plus h, t naught is 16 plus 2, that is 18, v of 16 over of 2. Now we have to find v of 16. This is equation number A. We have to find v of 18 and v of 16. V of 16 is actually equals to 2000 ln 14 into 10 by power 4 divided by 14 10 by power 4, 14 10 by power 4 minus 2100 t, t की जगह पे 16, and whole of thing 9.8 times of t, t is 16. Here we can approximate the value. Similarly for 18 we put 14 10 to the power 4 over 14 10 to the power 4 times minus 2 1 0 0 16, sorry 18. This would be 18 minus 9.8 times of 18. This is approximately equals to 453.02, 450, oh 392.07, 392.07 meters per second, and at 18 453.02 meters per second. This is the velocity for 16, this is the velocity for 18. Therefore, final equation number A, therefore equation A becomes, so therefore equation number A of 16 is actually equals to V of 18 is 453.02, 453.02 minus 392.07 divided by, we have 2. Finally, acceleration at 16 seconds is 30.47, 47 meters per second square, unit of acceleration. And this is the acceleration using forward difference method. तो हमने acceleration कैलकुलेट कर लिया. Now अगर वो फर्दर पूछता है बाउंडेड एरर, तो आप बाउंडेड एरर कैलकुलेट करो या एरर कैलकुलेट करो अगर वो आपसे एरर पूछता है. अदरवाइज वो एरर नहीं पूछता तो आप एरर कैलकुलेट नहीं करोगे. इन्होंने एरर भी कैलकुलेट करके दिखाया हुआ है. नॉट अ बिग इशू कि आप एरर कैलकुलेट नहीं कर सकते. आपने डेरिवेटिव ले लिया डायरेक्टली, एग्जैक्ट वैल्यू आ गई, एंड देन अप्रॉक्स वैल्यू आई, उससे आपने माइनस कर दिया, तो आप एरर को कैलकुलेट कर सकते हो. नॉट अ बिग इशू. Now moving further for second order derivative. This is called central difference formula for first order. हमने फॉरवर्ड किया था. अब अगर आप इसमें सेंट्रल डिफरेंस भी होता है तो आगे चलते हैं सेंट्रल डिफरेंस की तरफ. तो डिस्कस किया फॉरवर्ड divided difference formulation. f of x naught plus h minus f of x naught over h for all the values of h is very small. This is actually called forward difference formulation. Now नंबर नेक्स्ट है सेंट्रल डिफरेंस फॉर्मूलेशन x नॉट प्लस h x नॉट minus h or 2 times of h. This is called central difference formula for order 1. And example for this, minus h square over 6. तो इसका एरर बाउंड भी मैं लिख देता हूँ. Where even lies between x naught minus h and x naught plus h. टेलर्स पॉलिनोमियल सीरीज से इसको ड्राइव किया गया है h over 6 f3 the third derivative of e of it, or bound error will be equals to h over 6 f of eta third order derivative. Okay, this is the bound error. Now second order difference formula, centrally difference formula, that is equals to f double slash of, this is at x naught, this will be at x naught. Similarly at x naught, this is at x naught. Particular point, okay, x naught, this is for at x naught. So second difference formula, order 2 सेंट्रली डिफरेंस फार्मूला है. ऑर्डर 1 फर्स्ट डेरिवेटिव को कहते हैं, ऑर्डर 2 सेकंड डेरिवेटिव को. सेकंड डिफरेंस, सेंट्रली डिफरेंस फार्मूला में सेकंड ऑर्डर को आप कैसे लिखोगे उस पर बात कर रहे हैं. एफ ऑफ एक्स नॉट माइनस एच एंड minus 2 times f of x naught came from Taylor's polynomial series plus of x naught plus h, and whole thing will be divided by h square. Whole thing divided by h square, and error bound Bonding error is actually equals to h square by 12, fourth order derivative. This is error bound. Now we are solving example. Function x e of x at x naught 2, use second order to approximate 2.0. Okay, सॉल्व करते हैं. यूज फंक्शन है हमारे पास x ex and at x naught is equals to 2, and h is equals to 0.1. अप्रोक्सीमेट किस पे करना है भाई? 2 पर करना है. फाइंड सेकेंड ऑर्डर डेरिवेटिव और at x is equals to 2 using central difference formula. Difference formula या फिर midpoint formula is also called midpoint formula. Order 2. Order 2. Okay. Now solution. सेंट्रल डिफरेंस फॉर्मूलेशन जो है ऑर्डर 2 की, it certainly required few things. That is f of x naught plus h is 2 of x naught minus h and over of h square. This is actually formulation. Okay. Now in this data we have here x naught is 2.0 and step size is 0.1. Therefore therefore x naught plus h square and x naught is actually 2.0. 2.0. 2.1 minus 2f of 2.0, that is 1.9. We have 0.1 square and the function is xex. F of x is xex 2.1 e to the power 2.1 minus 2 2.0 e to the power 2.0 minus of 1.9 into e to the power 1.9. Finally, we have 2.29.593200 हमारे पास अप्रोक्सीमेशन होगी 29.593.59300. This is 25.593.200. सही है. At step size is 0.1. और similarly, अगर step size is 0.2, if the step size is is 0.2, that would be 29.704275. At h is 0.2. So when the step size is increases, the values will in given values is also increases. Step size increment होने पर values increase कर रही हैं, means it increases probably error. So how can we find the error? We can easily find the error by taking the exact value. Exact value. How can we find the exact value here? F of x is x ex. The first derivative will be u into v. U derivative of v plus v derivative of u. Okay, and x ex plus e power x. You can put the value first derivative and again taking the derivative of the term. x ex का derivative क्या होगा? x ex plus e power x. e पे power x का e पे power x. तो 1 plus 1 2 x plus 2 e power x. This is the second derivative. And if we put 2 in the equation, we get 2 plus 2 and e of 2, that is 4 times e of 2, that would be equals to 29.55622. 29.556226224. This is, we can say, exact value. Up to 6 dp. 29.5562224 and approx value at 6 dp is actually equals to what? 29.593232. 3200 at 6 dp, and error would be true value, yeah, exact value minus approx value, 29.556224 minus 29.593200, and it would be 0.03 7 0 approximately, means minus में this would be the error. Step size at h is equals to 0.1. If we take the absolute error, it would be positive. Okay, and this would be your task exercise. Here we have a task exercise.